Education, education, baby. Come on, education has no end.
Hello students, welcome again to a very interesting lesson on noble gases. These are elements in group 8 of the periodic table. They include helium, neon, argon, krypton, and xenon. They have a stable electronic configuration and therefore do not react under normal conditions. They were previously known as rare gases or inert gases, but these names proved to be a misnomer. This is because argon at 0.93% is more abundant than carbon dioxide at 0.03%. Therefore, we no longer call them inert or rare gases, but we call them noble gases. Some noble gases react under extreme conditions. For example, xenon combines with fluorine to form xenon fluoride. But generally, noble gases are inert, as they have a stable electronic configuration, and also they exist as monoatomic gases, that is, single atoms. They have a valency of 0. Now, the table below shows some trends in physical properties of noble gases, starting with helium, neon, argon, and krypton. Their chemical symbols are as shown. The one for helium is He, the one for neon is Ne, the one for argon is Ar, the one for krypton is Kr. They are all colorless gases with atomic number 2, 10, 18, 36 respectively. The atomic radius, as we can see, increases down the group. The first ionization energy decreases down the group. The melting and boiling points of these inert gases decrease down the group. Now, the physical properties of noble gases. Number 1 is that they are colorless gases at room temperature. All of them are colorless. Number 2 is that their atomic radii increases down the group due to increase in the number of occupied energy levels. So the atomic radius increases down the group, and the reason is because of the increase in the number of occupied energy levels. Atomic masses increase down the group due to increase in the number of protons and neutrons. We know that atomic mass comprises of the sum of protons and neutrons in the nucleus. Therefore, as we go down the group, there is an increase in the number of protons and neutrons, and therefore an increase in the atomic masses. Noble gases have low melting points and boiling points due to weak van der Waals forces of attraction between the atoms. We know that van der Waals forces of attraction are very weak forces which are easily broken, and therefore noble gases will require very little amount of heat to break those bonds. Therefore, that is a fact that they have low melting and boiling point. The strength of interatomic forces of attraction increases with increase in atomic size. That is why the melting and boiling point increases down the group. So, as we said earlier when we were learning about halogens, as we go down the group, there is always an increase in the atomic size because of the many energy levels. And that is why the forces of attraction between the molecules increase, between the atoms increase, and therefore the melting and boiling point also increases down the group. Noble gases have the highest ionization energy because they have a stable configuration. Now, ionization energy is the amount of energy required for an atom to lose electrons in the gaseous state. So you realize that because of the stability of noble gases, they require a lot of energy for you to be able to pull an electron from the outermost energy level. That is why we are saying the ionization energy becomes, is highest. It is highest in noble gases because of that stable configuration. Let's look at the trends in chemical properties of noble gases. Noble gases have a stable configuration as their outermost energy level is completely filled with electrons. Hence, they do not react under normal conditions. However, as you move down the group, atoms of noble gases with large atomic radius like krypton and xenon are able to lose electrons as they are very far from the nucleus and are weakly attracted by the positive nucleus. So as we go down the group, some of those atoms with the very big atomic radii will have their electrons easily lost because they are far away from the attraction of the nucleus. So it is important to note, even though noble gases are a stable configuration, the ones which have a very big atomic structure may react because their electrons can be easily lost because of the loose attraction from the positive nucleus. Uses of noble gases. Neon is used in the advertisement and disco lights. Argon and krypton are used to fill electric bulbs and fluorescent tubes to prevent oxidation of the filament. Helium and argon are used to provide an inert atmosphere during welding. Helium is used in filling airships to increase their buoyancy. A mixture of helium and oxygen is used in deep sea diving and mountaineering. Neon is used as a refrigerant. Xenon is used in disco lights. There are so many other uses of these noble gases, but we have just stated a few. And you realize that the chemistry of noble gases is very little because of the fact that they are unreactive. So we don't have much to talk about them, and that is why we just have little to talk about in noble gases. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.
Education, education, baby. Come on, education.